Alright, so now we come to the second half of this particular program, which is program 2. Alright, so what we have is we have to enter a number into, we have to convert a number into its binary, octal, and hexadecimal form. So we have to take that number from the user. So let's first cut this statement out. Alright, bring it to our real programming scenario. Alright, so we want this statement, alright, to be given to the user. So I'll put double quotes at the end. We don't want this value over here, we want this value to be given by the user. Alright, so we put double quotes over here. We give this particular statement which is a string to input. Alright, and whatever is the value that we get from the user, we will save it into let's say a number. Okay, so a number या फिर num. Alright, so a num variable which has, not a none, a num variable which will take this value and store it into number. Now of course, since it is taken from input, as we saw over here, we'll have to typecast it, right? We have to typecast it into the integer type. So it will be int function which will take this input and convert it into integer. Alright, so now we have our number into an integer form. So what do we want next? We want to convert it into its equivalent binary. Alright, now what is a binary? It has only two representations, right? So it has only 0 and 1. Alright, so we'll see an example. We'll see 2-3 examples, and then maybe you will get a clearer idea of how these representations work. Alright, but anyway, let's see this. Type is, and type is, so type is given by type function. So we'll have type and then say bin. No, let's just have b variable. Alright, so we'll say that b is the variable which will be used over here, and instead of this we'll have the same b variable. Alright, we have to concatenate it, so there will be a comma operator in between, right? This is a string, so let's cover it into double quotes, in double quotes, and then the comma operator, right? It's the concatenation operator. So now we go to the end. Let's wait a minute. Let me see this here. Alright, and then here. Okay, so we have this particular so we have this particular string first, okay, followed by a variable b, alright, followed by this particular string, and then followed by this particular function. Okay, all of these are given to print function. Alright, so print function will take all of this as input. Okay, so print statement takes all of this as input. Alright, now we haven't converted the number into binary, right? If you see, the number is still into its when we take this number, we expect this number to be an integer. Okay, so integer is expected. Alright, what is expected is an integer, right? So we say enter a number to convert it into binary, octal and hexadecimal representations, right? And what we expect is an integer. So what we have to do is, next step is we have to convert it into a binary. So the functions are simple, very simple. B equal to bin, and that will take an integer value. So that is why we had to convert this number into its integer representation. Okay, so now we give num as input. Okay, so b equal to bin number. All right, now let's see if this particular program works. All right, now if I run this program, I have all this data from above, right? That will also run. So what I have to do is I will comment this particular part, the previous part. All right, I use multi-line comments. Okay, not really multi-line comments, but multi-line strings, right? Which are not assigned any variables technically. That is a correct term, but we'll call them multi-line comments for simplicity. Okay, so basically our program is just taking a number from the input, converting it into an integer. Okay, and then we are converting it into binary and then checking whether it is actually binary or not. So let's save this file and run in this file. So yeah, run this file. Okay, so let me see if this one works now. Yes, Control L to clear this particular screen. Command L, Control L to clear this screen in Windows and in Ubuntu and in Linux and in any Linux or Mac OS. And if you want to clear it in Windows, just write CLS and hit enter. It will clear the screen. Okay, those commands are not lost anywhere. It will be just up. So if you scroll up, you can see this. It's just better to have a clean window when you are working on something fresh. Okay, now let's run this. Oh, sorry. This. Alright, so the number that we want to give, let's give 4 for example. Does it work? It works, right? So it's 4 and it is string. Alright, so why is it not binary? Alright, so the reason it is not binary is because this, if it writes, 100 is the actual output of binary. Alright, and 0b is the code associated with it, and it is saving it as a string. Alright, the reason being, you can save different values in strings, right? But if 0b is associated with the type, then basically string as I said earlier, string can accommodate various data types or various characters, right? It can accept numbers, it can accept characters, and it can accept special characters, right? That is why it has this representation. It does not have a separate binary or octal or hexadecimal representation. How does it recognize it though? It just simply appends 0b or 0o or 0h in front of that particular representation. Okay, so let's try another number. Okay, we'll give this and write 254, enter, and that is the representation. Okay, 0b is the code and this is the representation. Alright, so what has happened here? You can see since it has the maximum of maximum representation power of 2, so 2 to the power 0 is the least value. Alright, 2 to the power 0 is 1, 2 to the power 0, then 2 to the power 1, then 2 to the power 2, and so on, right? So that is how it works. Okay, now let's see the other two, right? That is the octal and hexadecimal. Since we have already taken the number, right, what basically is remaining is what remains is basically to convert them into the those numbers, right? So all right, so we have O equal to, so O equal to OCT, sorry, OCT and the number, right? And here, since we want to print it, and it will be this, the equivalent octal number is, and here we want to replace it with the number, so I'll give comma as the concatenation operator, then O, which is the number, then this type is a string followed by a concatenation operator and function type O. Okay, complete this, sorry, not this, complete this, and we are done. Alright, similarly, when we have this one, I'll just take this particular one and replace it with over here, Control V. Now in hexadecimal we don't have B, we have H, a variable called H, a variable by the name H, HEX is the function which will convert the number into a hexadecimal representation. Okay, here it will be H, the type remains as it is, this will be hexadecimal. Okay, so equivalent hexadecimal is, and the type is not B but H. Okay, now let's just save this and watch this in action. Alright, so when I give, oh sorry, type is in O. Type is O, wait, what just happened? Literal detected, unterminated string literal detected. Alright, so I did not terminate this over here. Alright, so this first literal, the string, it had to be completed, right? Only after I complete that can I add something else over here. So that was the case happening. Then I save it, I go back, I run this program. First let's convert something simple. Okay, so hexadecimal has maximum representation capacity of 16. Okay, so it has 16 different unique numbers, so from 0 to 15, right? So 0 to 9 is regular numbers, and then we follow alphabet. So let's convert 15 and see what happens. Alright, so when we convert 15, alright, the binary representation is all ones, 4 ones, right? It says 1 1 1 1. Alright, when it comes to octal, since it has 7 representations, it goes up to maximum of 7 over here, and then it takes 1 in the most significant bit. Alright, it adds 1. Alright, so what is 15 in decimal representation, that is the numbers we use in daily life. What is 15 in regular usage, okay, is 1111 in binary. It is 17 in octal, okay, because octal has 8 representations, right? Decimal has 10 representations. So it has 117, 17, that is 17. And in hexadecimal, when it comes to hexadecimal, it is a single digit F that represents 15, correct? So that is how numbers are represented. If we take a bigger number, 1 2 2 3 4, I'm so sorry, I did not run the program. So let's first clear the screen, okay, control L. If I run the program again and give it a bigger number this time, okay, 4 5 6, enter, you will see that binary has a bigger representation followed by a smaller representation in octal number, and an even smaller number in hexadecimal, okay. So see, the most significant bit over here is 7, okay, and it is to the third place, right, but it is 7. In hexadecimal it is 1. It is to the third place, but it is 1, all right. So it is just getting started. So that is how powerful the representations are, all right. So we'll stop over here and we'll move to the next program in the next video. Thank you.